This is a support video for National 4 and 3rd year Analogue Electronics, and this is Task 9. And Task 9 is essentially the same as Task 8, only this time the engineer with the same circuit. However, instead this time we've got a 12 volt supply and the engineer is stuck with the 12 volt supply, and that's going to cause us some problems. So to try to investigate that, we're having a little observation in what is happening to a lamp when the switch is closed. So if I close the switch, which will then allow current to flow from the 12 volt supply voltage rail down to the 0 volt voltage rail, then we'll have a fault in our circuit because the lamp sadly explodes. Now, I've opened up the switch again so that no current's flowing, and now I've fixed the lamp. However, we've got an issue, and essentially the issue is that there's too much current flowing through the circuit. So we need to try and find a way to reduce the current that's flowing in the circuit. However, what we can't do is a little cheat by changing the supply, because the electronic engineer has only got a 12 volt supply available. Now, way back earlier in our tasks, and if I recall correctly, it would have been task 2, we came across a device called a resistor, and the function of a resistor is to help to control the flow of current in a circuit. So if I come into the basic components folder, in the symbolic folder, I can find myself a resistor, and so it might be a good idea to place a resistor somewhere in the circuit. Now I can do this absolutely anywhere in the circuit, but it's probably easiest for me just to place it immediately after the lamp in series running into the 0 volt rail. And now, if I close this switch, we've got little arrows to indicate that there is current flowing through the circuit, including through the diode that only allows current to flow in one direction, and we can see that there's a tiny current flowing through here, 14.5 amps. However, the lamp isn't lighting up, so we've still got another issue there, which is that we've probably controlled the current a little bit too much, and so we need to alter that value. So if there's not enough current, that means that the resistance is too high, so I will change this to a much lower value than the 680 that we had before, and we'll try using 100 ohms this time. And now if I close the switch, we can see that the lamp illuminates and the current isn't too high so that the lamp doesn't blow.